topic is the missing density constant in classical physics. The subtitle is Why Unification of Gravity Has Failed. I want to show you that the problem preventing unification has never been gravity or quantum mechanics themselves. It's the way classical physics defined space. Physics introduced the speed constant c, but it never introduced a corresponding density constant. That missing piece, I give it a simple mu space, is the reason gravity and quantum mechanics have remained conceptually incompatible.
Excuse me, Lin, is the slide advancing?
Not yet. It's still on the title. I just want to give some kind of a, abstract.
Okay, sure. Thank you.
So once we recognize the space as a physical medium with both speed and density, the entire landscape of constants, including hbar and g, takes on new meaning, and the unification becomes possible. So the overview of...
Excuse me, Richard asked you to make the presentation slide as a full screen mode.
How do I do that? Let me
see. This is a PowerPoint.
Yeah,
push play at the top of the screen.
Push play.
Yeah,
the play button.
Yeah. Okay, here.
Yeah.
Okay.
Play slides.
Okay.
There you go.
Thank you very much. Yeah, this is a new laptop. It's I'm not so familiar with it yet. Okay, so good. Overview. This talk is structured in a very simple way. First, I'll show that classical physics treated space as empty, even as we built theories that depended on its physical behavior. And then I'll identify the structural imbalance created by having speed but no density constant. And then I will show why all real media require both speed and density, and why omitting the space density broke the foundations of both gravity and quantum mechanics. Finally, I'll show you how John's helical motion framework restores that missing structure and naturally unifies the constants. Okay. Classical physics. Historically, space was considered empty, a passive stage where physics happens. But every major theory contradicts that assumption. Maxwell showed space carries electromagnetic waves. Einstein showed it bends. Quantum field theory shows it fluctuates. These are not properties of nothing. They are properties of a physical medium. But because classical physics never acknowledged that, it never gave space the full set of properties any physical medium should have. We formalized the universal propagation speed c, but we never defined a density constant. Imagine describing water waves with only the wave speed, but without water density. That theory would be incomplete. But that is exactly how physics has been describing space. We accepted the speed limit of the road, but we forgot to define what the road is made of. As a result, gravity became curvature with no substance behind it, and quantum mechanics became action with no medium carrying it. The divide between the two theories was built into the foundations from the very beginning. Physical media require two properties. As every physical medium that carries waves need two things: a propagation speed and a density. Air has density that determines how sound spreads. Water waves rely on fluid mass. Solids need stiffness and mass density. Space is the only medium in physics where we recognized its wave speed c, but never assigned its density. That asymmetry is not physical, it's historical. And it is the root cause behind the failure of unification. You see, we have spent 100 years focused on the wave line, but what is the background? It's moving through. In John's model, space moves helically at the speed of light, and this motion contains three independent directions. The radial direction, it is expansion or contraction of the helix along the radial direction. It determines how space accumulates or releases curvature. This degree of freedom governs the gravitational structure. The response of the medium to radial deformation requires a density scale, which is precisely what the density of space quantifies. The y-axis, it is the axial direction. Along the axis of the helix, the motion preserves the alignment but varies phase. This produces a rotational coupling that expresses itself as electromagnetic behavior. Maxwell's equations emerge from this axial structure when the helical motion is projected into three-dimensional space. Torsional direction, x-axis. Around this axis, the helix carries continuous angular rotation. This torsional component produces a universal quantum action expressed as hbar. Quantum phase, interference, and discrete energy levels arise directly from the torsional geometry of space. The torsional inertia of the medium again requires a density constant. Without space density, hbar would have no physical origin. Crucially, while the rotation of the torsional axis is continuous, its physical effect is quantized. Think of it like a clock hand. The movement is smooth, but a day only registers once a full circle is complete. In this medium, a discrete quantum of energy represents exactly one full 360-degree rotation of the torsional axis. This is why energy levels are discrete. You cannot have half a rotation and still maintain the geometric integrity of the helical wave. We can look at the horizontal torsional axis. In Young's framework, this isn't just an abstract direction. It represents a continuous twist or angular rotation of the medium itself. Where the motion is continuous, the physics emerges in cycles. One full 360-degree rotation of this axis is what we mathematically experience as a single unit of action. The second part, the missing constant. Mu, the space density, represents the inertia of space, the medium's resistance to deformation and curvature. With C alone, space has a speed scale, but no mass scale. Once mu is recognized, space becomes a complete medium, capable of storing energy, transmitting curvature, and supporting motion. Without mu, we've been trying to build a unified theory using only half the medium's properties. Zhang and Xu previously introduced a fundamental constant of space written as mu g instead of mu s. They use it to derive both g and h bar within their geometric framework. Their work demonstrated that mu g is an intrinsic property of space from which gravitational structure and quantum action arise, completing a unified description based on helical motion. However, the subscript G does not clearly indicate that the constant represents the density of space. Instead, it can suggest a gravitational coupling or even an implied direction of dependence between the constants, potentially reversing the conceptual relationship. So I rewrote that symbol U with a subscript S to clarify its physical meaning. It is the density constant of the space medium. Gravity and quantum action emerge from the properties of space, not the other way around. Clarifies why classical physics remained incomplete without such a density parameter. Zhang and Xu's paper, I have the link at the end. I actually did a presentation on their paper during that American Physics Association annual meeting for the Mid-Atlantic session last month. It is in the campus of Penn State Harrisburg campus. Originally, I planned to talk that paper, and then I changed to this one. I think this one can have a full picture of John's theory. If at the end you're interested in that paper, I can do a presentation on that as well, since I have already prepared, delivered at the conference. I could just pull that slides up. Okay. Why I cannot advance to the next page? I cannot advance to my slide.
Maybe switch back to the normal view and go to the go switch back to the normal view like before.
It's not doing anything. Oh, that's strange. It's like frozen, but okay, moved.
Yes, I can see. I can see the slides advancing. Yeah.
Okay, but I don't see. I need a 13. So it's too much. Okay, here. Okay, so quantum mechanics revealed something classical physics couldn't explain: the universality of hbar. Quantum phase interference, vacuum fluctuations, all of them pointing to an underlying medium with intrinsic action. But H has always been treated as a mysterious constant with no connection to space. If space has density, then hbar becomes a natural expression of space's internal structure. Quantum mechanics was not strange. It was signaling that space had a missing property. Electromagnetism gets its speed from space, but no density. General relativity gets curvature, but no resistance to curvature. Quantum mechanics gets action, but no medium carrying that action. Each theory grabbed one piece of the puzzle, but none describes the full physical medium. The absence of space density made it impossible to connect them conceptually. Unification wasn't failing because nature was too complicated. It failed because the foundation was never complete. Part 3, why unification failed. Unification failed due to incomplete foundations. Gravity is space, described as space as geometric structure that curves. Quantum as arena for discrete action and interference. Without space density, no complete physical characterization of space. That's why gravity has geometry without substance. Quantum has action without medium. Incompatibility built into starting assumptions. Because space had no density constant, G had to be treated as an empirical parameter. There was no way to derive how strongly space responds to energy or how curvature propagates. But in a real medium, curvature must depend on density. The stiffer or denser the medium is, the more or less it curves under stress. With the space density defined, G becomes the medium's resistance to curvature, not a mysterious constant we simply measure. H bar shows up everywhere. Angular momentum, spectra, interference, but its origin has always been unexplained. Without a medium, H bar becomes a purely quantum artifact. But if space has density and internal motion, H bar becomes a geometric quantity, an expression of that motion. With the space density, the quantum and gravitational constants finally refer to the same medium properties. With the space density, the entire structure becomes symmetrical. Speed c describes how fast the medium transmits information. Space density mu s describes how much resistance the medium has. H bar becomes angular action carried by the medium. G becomes the amount of curvature produced by energy in that medium. All constants now point to the same physical object, space as a moving, structured medium. The fourth part, Planck's constant reconsidered. The universal role of H bar. H bar governs phase interference, fluctuations, and angular momentum. The fact that it appears everywhere suggests it cannot be a property of particles. It must belong to something universal, the medium embedding all systems. Its universality is a signature of the physical nature of space. Traditionally treated as the exclusively quantum parameter H bar, but H bar appears at atomic spectra and interference patterns, angular momentum definition, phase space structure, quantum field fluctuations. So universality suggests H bar is geometric, not just quantum. Unified interpretation, H bar is geometric. In John's framework, space moves helically at light speed. That motion naturally carries angular action, which manifests as H bar. Small systems can resolve this torsional structure. That's quantum mechanics. Larger systems average it out. That's classical physics. The classical quantum divide becomes a matter of resolution, not ontology. If you ask a person standing in a field if the Earth is flat, they'll say yes. The local data supports it. They're averaging out the curve. This is a classical view of space. We feel it. It is an empty, flat vacuum because we are microscopic. But just as a satellite reveals the Earth's true geometry, a quantum experiment reveals space's true geometry. A grainy helical medium where every step is a full 360-degree rotation. The flatness of classical space is simply a consequence of our scale. To understand why we perceive space as a smooth, continuous vacuum instead of a grainy helical medium, we only need to look at our own history with the shape of the Earth. Why did humans feel that the Earth was flat for millennia? The local perspective, the classical view, at our scale, walking to the store or looking at the horizon, the curvature of the Earth is too slight to detect. Our senses average out the massive sphere into a flat plane because our sampling size is too small relative to the total circumference. This is exactly how classical physics views space. We are so large compared to the helical grain of the medium that everything looks flat, smooth, and empty. The global perspective, quantum perspective. It is only when we use high precision tools or travel at extreme speeds or scales that the flatness is revealed to be an illusion. In physics, the quantum field is like a satellite. It is sensitive enough to see the curvature and the grain, while our everyday experience averages out the torsional twists of space into a flat vacuum. The quantum scale detects the individual cycles, that is hbar, that prove the medium is structured and moving. The greatest mystery in physics has been why the world looks smooth at our scale, but grainy at the atomic scale. In this framework, the answer is simple. It depends on whether your measurement is sensitive to a single cycle of the medium's motion. The quantum view with high sensitivity at the subatomic scale. An electron or a photon is small enough to interact with a single twist of the helical medium. Because the medium has a physical structure, these particles must complete the lap of one rotation to register an effect. This is why we see discrete energy levels and interference. The quantum field is detecting the individual cycles of the torsional axis. The classical view that average out. Now imagine zooming out to the macroscopic level. At our scale, we aren't measuring single rotations We are measuring trillions upon trillions of them every second. At this scale, the bumps of individual rotations average out into a smooth, continuous flow. It's like looking at a digital screen. Up close, you see the discrete pixels, that is quantum. But from across the room, you see a seamless image, that is classical. The unification. The Planck's constant, hbar, isn't a limit on reality. It is the unit size of the medium's wave. Classical physics missed hbar because it only looked at the finished tapestry, never the individual threads. By recognizing hbar as the geometric torsional action of space, we realize that the quantum and the classical worlds aren't two different places. They're just two different ways of looking at the same physical medium. I hope this slide is explained enough. Cannot advance again. I don't know what's wrong with my... I cannot advance again. That's weird.
Try to escape from the presentation mode.
Yeah.
And then play again.
I'm trying to, it doesn't do anything. I'm so sorry. Okay. Okay. hbar as evidence for physical nature of space. hbar controls fluctuations, phase, and action across all physics. Those are not properties of empty space. They are properties of a medium with structure. If space has angular action, then it must also have density. Space density is the only way to complete the medium. Part 5, John's unified field theory. John proposes that space itself moves helically at speed c. This motion gives space intrinsic structure, angular action, and resistance, exactly the properties missing from classical physics. This model produces the density constant naturally, not artificially. Helical motion explains hbar naturally. In a helical medium, angular action is intrinsic. That explains the universality of hbar. It also explains why quantum interference is sensitive to phase, because phase is the geometry of the medium's torsional cycles. Classical behavior arises when these cycles average out. Helical motion requires density constant. No medium can carry helical motion without inertia. The density constant mu s reflects that inertia. It quantifies how the medium responds to energy, phase, and curvature. This completes the physical description classical physics could not provide. This theory does not contradict relativity. The helical motion is universal to the medium itself, not a preferred frame. All observers experience the same structure, preserving relativity. The field equations remain fully valid. What changes is a physical interpretation. Curvature becomes a deformation in a moving medium, not geometry in a vacuum. Once the medium is complete, all constants C, h bar G was no longer disconnected empirical values. They all arise from the same underlying geometric and physical structure. This restores the unity physics has been missing. The implications. Clarifies meaning of fundamental constants. Each constant now has a clear physical meaning. C is the propagation speed of the medium. H bar is the angular action of the medium. G reflects the medium's resistance to curvature linked to space density. These are not separate domains. They are aspects of one substance. Restores theoretical balance. Both gravity and quantum mechanics become descriptions of the same medium viewed at different scales. Gravity captures large-scale geometric behavior. Quantum mechanics captures the fine-scale torsional structure. The space density is a key that ties them together. The division isn't fundamental, it's scale dependent. Systems that can resolve torsional cycles appear quantum. Systems that average them out appear classical. This continuous view removes the artificial boundary between the two regimes. Implications for fields and energy. If space has motion and density, then energy transfer, curvature, and phase behavior are all interactions with the medium's structure. Gravitational waves become perturbations in helical motion. Quantum interference becomes engagement with torsional cycles. This brings all fields under one coherent interpretation. Future research directions. With the medium identified, many paths open. Measuring vacuum energies through space density, detecting signatures of helical motion in gravitational systems, explaining quantum phases from geometry, and designing experiments that can confirm or falsify that model. The theory becomes testable. Conclusion. The core failure of classical physics was not recognizing space as a physical medium. Without space density, gravity and quantum mechanics were built on incompatible assumptions. Adding space density restores the missing foundation. Space behaves like a medium in every observable way. It carries waves, stores energy, fluctuates, and bends. The universality of hbar is evidence of intrinsic structure. These facts point directly to the need for a density constant. John's helical space supplies the missing structure. It gives physical meaning to all constants and links them through the medium's geometry. It provides the first coherent physical explanation for the roles of C, hbar, and G together. Resolving the central long puzzle. Unification failed, not because nature is incompatible, but because space was never fully defined. Recognizing space density solves the conceptual gap and unifies gravity and quantum mechanics under one medium. Once we accept space as a moving medium with both speed and density, the path to unification becomes straightforward. The constants align, the classical quantum divide dissolves, and a coherent picture emerges. The missing density constant is the key. Key takeaways. Space is a medium. All media require speed and density. Space density fills the missing gap. hbar is geometric. John's helical model gives physical meaning to all constants. And with a complete medium, unification becomes possible. Okay. Thank you. Welcome your questions, especially your challenges, because the goal is not belief, it is testing. A complete physical theory must be falsifiable, and this framework defines clear experimental paths to verify or disprove it.
I see a question from Ron. He asks, is the density S a scalar, vector, or matrix, or etc.?
Can I see the can I read the question? Can you read the question again?
Is the density S
your constant mu sub S?
Mm-hmm.
You refer to it as a constant, but is it a scalar, vector, matrix? How do you define it?
It is a constant. However, the value of this constant may vary, though, because it's just like density of air, for example. It could be different. How to describe it? Yeah, the space density is not, although it is a constant, but it's not a single value. That's how I understand it at this point. Germ theory has become quite popular in China. There are many researchers, all dependent researchers. They have written different papers defining different values for that constant. I have not done that detailed research myself, but I have seen there more work.
So to represent that as math, it's just a scalar that has functions that can change it?
It is, I think the density, the word density is very accurate. It is a mass over a Q volume. It is a resistance of the medium to motion. So the concept is clear. I understand it exactly as the word density, what the density means.
Density can mean a couple of different things. There is a mathematical meaning to density that's often used even in probability theory or measure theory, but it could also simply be kilograms per meter cubed.
That is my understanding, like a gram over a cube of a meter, that volume. Yeah, that's my understanding.
All right. I think Ron was trying to, since we're dealing with physical quantities, normally we have scalars, we have vectors, we have, especially in general relativity, we have tensors. I think he was trying to ascertain what is this constant just a scalar? Like H could be thought of as H bar as a scalar. You can think of that as a scale. It's a number. It's actually a constant. This apparently, what you're saying is this constant is not really constant. At least it can change, I guess, in different people's theories. Although, is it a constant within any one particular theory? Is it constant throughout the theory? In other words, is mu something that would change from point to point in space, or would it actually be constant in space?
Okay, this is undefined yet. John's theory is not a complete theory. His book only give us the idea of the theory. Although it has some formula, they need to be further defined. We recognize that. And also his theory has not been accepted by mainstream physics. So all current researchers are independent researchers like myself. I'm not a physicist myself. We are lack of resources. But from my understanding, I think this is the correct direction. That's why I want to spread the words so that more people may be interested and take a look. They have designed experiments with quite the details. So it could be, it is already testable, I think. I'm just trying my best to explain it, but that's what I can understand. There is a website. It has published papers. It is on the next, yeah, here. Yeah, the paper.
So you're actually your profession or background is actually a translator. You actually are trying to translate from the Chinese into the English.
Yes, my full-time job is a senior IT security analyst. My field is information and technology.
I see. Okay.
They are in China. They don't speak English. So when I first encountered this theory, immediately I felt I have to do something. First thing is to translate so that at least English-speaking world can can read it. So that's why I translated his Unified Field Theory. I call it academic edition. It's just comparably to his own original, but it is not real academic. But I just made it, frame it as add some abstract, add some introduction. Yeah. So anyway, yeah. I'm mainly a translator for this theory. I did a little research on my own, such as today's presentation is my understanding of missing, what is a critical missing part of current physics.
Well, there are some things that one could get somewhat technical in the physics. Like, let's say this, for example, the idea of space being fundamental. Well, let's say perhaps space-time. It's not entirely clear what role time has in this theory, but space being fundamental kind of runs somewhat refreshingly opposite of the current trend in fundamental quantum mechanics, where space is regarded as being emergent from concepts of information, for example. And obviously that in turn ties into things like quantum field, black hole physics. But this is somewhat kind of a reversal of that. There are other questions that could be asked. For example, in differential geometry, there's a concept, which is where the concept of curvature comes from. There's another concept, less physically obvious, as unlike curvature. You can pick up a ball and this thing has curvature. But there's a thing called torsion. I suspect that in this use of the word torsion is just to get an idea of twisting, whereas not the differential geometric concept, but maybe there might conceivably be some kind of a relationship within this theory. I suppose, given that there is a proposal that space itself is a density, one might ask, and you saying it's continuously in motion, one might ask, well, how can it stay continuously in motion? What is causing it to stay continuously in motion? Usually, motion requires some kind of impetus, and of course, Newton showed that if you don't interfere with it further, it will stay continuously in motion. But some energy must have gotten that motion going at some point in time. Was that at the Big Bang, for example? Was that motion started at the Big Bang? One can ask questions like that. But yes, I understand that apparently the theory is not completely fully developed, so maybe those ideas will be taken up. I mean, I myself proposed about 20 years ago the idea that perhaps dark energy, which is pervasive, could actually be regarded as a sort of a substratum in the universe, and might even be able to explain why you could have things like supposed entangled action at a distance effects, because in effect you have one effective substance, not entirely separate substances in the universe. But I did not conceive of something along these lines specifically. But anyway, very interesting, and my commendation to you for trying to present this to a technical panel here. That's an impressive and courageous thing to do.
Thank you. Yeah, actually, since you mentioned this theory actually has answers, I try my best to explain with my limited understanding. Time in John's theory is it is not independent at all. It is a measurement of the motion, how much it has moved. So that actually exactly the time and distance are one in his theory. So time is just the measurement of how much the motion has advanced in that radial axis. And also the black hole he also explained if the helical, he actually, not just a helical motion, it is a cylindrical helical motion. That's his exact words in his book. I didn't put it in this paper because it is not that easy to explain why it is cylindrical, and then it is also helical. But their paper already, they are all preprint. None of those papers has been accepted by mainstream those journals. But in that SSRN, their papers explain how that black hole is explained by his theory. Yeah. They actually, interestingly, there is a convention for his theory happening tomorrow, like tonight here in China. And there are over 40 papers were submitted. I submitted this paper as well. I translated into Chinese and submitted. The over 40 papers will be presented at the convention. They're all supported by independent researchers. Some of them actually are school professors, PhDs, but they're not supported by their own organization. So they are doing research on this theory, not supported by the organizations.
I noticed Paul has a few questions. Paul, you are mute. Can you ask online?
I am here, yes. My question is, how far along is China in its understanding compared to the United States?
In America, all people I have talked to, they don't know this theory, not at all. I don't know many people, so I do not know. But his book is not, I mean, the book, not many book copies are sold either. Probably several copies a month. In China, it's quite popular, not by the in academic, not at colleges or research organizations, but by independent researchers, PhD students or PhDs or professors. There are many.
Are there any further experiments, any proven patents, anything that you can offer to lend some credibility to this?
Oh, yes. They actually have received a patent from the United States. It is in their website, unifiedfield.info. Unifiedfield.info. The official website. It has the patent information. Yeah.
They received a patent in the United States. It's not
Yes.
so much the United States, I'm surprised that usually patents, you can't patent fundamental physics. So they've actually derived some kind of a machine or some kind of device based on this theory that does something that can therefore be patented.
Yes, they did some experiments, and the experiments detailed in the website. They were able to induce the gravitational energy from a change of magnetic yeah, they did that experiment, and
They were able to induce a gravitational energy from the magnetic field.
Yes.
It's interesting.
Uh,
All right, that
they actually they would they have an investor. Zhang Xiangqian is a founder, creator of this theory. There are people. The second paper, key reference, the second one. Xu is actually a businessman. He sponsored Zhang to conduct the experiments. He provided the equipment to conduct the experiments. And also he said he would ship the equipment everywhere in the world if any physicists would want to replicate the experiments.
Have you ever met Zhang?
Yes, I did. I went to China. I met both Zhang and Xu. Yeah. The experiment, their equipment is very, very simple. You can imagine for theoretical physics, usually it requires a nation behind you to conduct those experiments. As independent researchers, it's extremely difficult. So their equipment probably like $1,000 equipment, but that's the best they could get. However, it already produced convincing results. They just hope that those scientific lab could just take a look and do that experiment. Even if you do it and then say, oh, it's totally unexpected, it didn't get expected results, this theory is proved wrong. But the current situation is nobody would even take a look. Yeah.
Is that your objective, to find collaborators here in the United States?
I hope I could. I don't know how much I can do, but yeah. I'm just an advocate of this theory. I try best to tell people about it. I'm very grateful I have this opportunity to present.
Can I ask you some question? I'm not so sure if it's the right place to ask. You gave a good presentation, very good, very insightful presentation. I just wonder about the mathematical foundation of this work. If the book that you referred in your reference contains all the mathematical foundation in terms of proof or demonstration of this unification.
Yes.
And also, I just wonder. Also, you talk about this the density of the space. I wonder to have the density as you describe it might have a kind of substance. What substance is that? Has been identified, the substance which interacts with space or gravity to generate this density.
Okay. Yeah. The density is okay. In his theory, that mass is determined by the resistance to this motion itself, and it is counted by the slice of that resistance. Yes, it has substance. In his book, it says the number of slices determined the amount of resistance that become the mass.
Okay, and also the first question I was asking about the mathematical foundation of this work has been done is in the book that's written is all the mathematics to describe this theory.
Yes, it has a mathematical description. However, it's not done. It needs further defined. The mathematical, I believe the mathematical also requires further defined.
And my last question, very quickly, the speed of light, which is a constant, a universal constant, which is defined by the Maxwell equations. So did Zhang produce a different derivation of the speed of light based on the space density?
Oh no, the speed of light. Okay, his axioms of this theory based on the space moves at speed of speed of light is the speed of the motion of the space. So that's how this theory explains why speed of light is constant, because the speed of light is the speed of space itself, and that is constant. That is axiom of this theory. It says the entire universe could be explained by space motion alone. So the space moves at speed of light in helical motion outward in all directions.
Yeah, okay, but he has not managed to develop a formulation which correlates the speed of light to the space density. Is there a formula or mathematics which correlates the speed of light to the space density?
That part has been done by the paper. I listed the second paper.
Okay.
Yeah, the second paper has that mass. Yes,
yeah,
and also, he has also been able to derive those existing equations from his theory. The existing the Lorentz equation. I cannot remember exactly. That's famous physics.
Is the Maxwell equations?
Maxwell. Wave equation, Maxwell equation, and also the Lorentz equation as well. Yeah. His theory has been able to derive those equations. Yeah.
Yes.
Yeah, those math work. The second reference, it is just one paper that directly related it to this to my paper. That's why I listed here. However, Xu, he himself is a businessman, but he has published a complete series of paper based on Zhang's theory. All his paper is listed in that official website, unifiedfield.info.
That's fine. Yeah, thanks very much. Thank you.
You're welcome. I just hope that with my effort will make a little difference. Yeah, during that annual meeting at that American Physics Association annual meeting, when I delivered this, I presented their paper, not my paper, during that conference. Two theoretical physicists actually were in the attended the session. Afterwards, I talked to them. They said it's very interesting, but they cannot help me because they are theoretical physicists. They do not do experiments. And then I asked, I said, so when you have a theory, don't you need experiments to check if it is valid? And they said, yes, but we have collaborating experimental physicists. Then I asked, I said, what if the theory is new, is completely new? Why would they collaborate with you? These two, they are quite young, in their 30s, proudly said, we only develop theories within our parameters. I just found it's very interesting. It's how the mainstream physics world work. So how could any new ideas could develop within that kind of mindset? And that, I think that's why over 100 years almost, there's no real advancements on the unification.
So in any of the papers that describe the math, did anyone claim they rendered it as code, like in Python, for analysis at all?
And yes, in their series they have a mathematical derivation. Yes.
But did they mention that they actually wrote some code to show an analysis or anything?
Not that kind.
Okay.
I think they only did just from the pure mathematical derivation.
Okay, thank you.
Yeah, we need more experts to take a look and see what can be developed.
While listening to this, I was actually going through the paper that was posted on the chat, the Zenodo paper. At least one of them. I don't know, not all of them or anything like that, that other people have helpfully found, like that patent and the other things, but there's not a lot of math per se in that paper. It defines the concepts well. Or the intention of the concepts, what they're trying to do. There's a diagram of what this helical motion is about, but the math is at the level of basically algebra or just even almost arithmetic, just manipulating and showing the relationships between the different known classical constants and these new density constants that are being introduced. So it is not the kind of math that would be, let's say, you'd find in a general relativity text or something like that.
Yeah. That's why I believe that math need to, there are a lot of more advanced mathematical work are needed. I mean, even Einstein, when he proposed his relativity, it was not that mathematical advance. Yeah, it was later developed by Maxwell, right? Yeah, this work needs a lot of more refinement mathematically and other scientific methods. But I just my instinct tells me this is the right direction, and that's why I devoted myself into this theory.
I want to pose a question. Unify field.info, is this the website you're referring to?
Unified field.info, yes.
And Paul also asked, any thoughts on what new technologies may be derived from Zhang's theory?
Oh, yeah. Yeah, they claim that with this theory, if developed, advanced artificial intelligence would be, yeah, it will, advanced artificial intelligence, like information, okay, brain could transfer brain information to a computer, and then the Neuralink, they claim that with this theory, that Neuralink will become so reality very, very fast. The brain can be transferred to machine and then transfer back to a body. That's how to achieve that eternity.
I could see that electromagnetic gravity artificially created can actually benefit all types of propulsion and movement without moving parts. That I would see as a huge advantage.
Oh yeah, that's his theory actually also, that because the mass is not an intrinsic property of an object, it is just the resistance of the motion itself. So by proper alignment of objects, the mass can be reduced to zero. That is a big claim in his theory. Once an object mass reduced to zero, it will instantly speed become the light speed. That's how photon works actually. And also with when an object reaches light speed, the distance between objects collapses to zero, to nothing. That is the mechanic of UFO motion. So how that so it is so it doesn't matter the distance between two objects anymore. It will be instant transfer from one location to another. Yeah, it's quite fantastic. So that's why I didn't want to mention it, since it sounds like a fairy tale.
Sci-fi.
Yeah, but
that also adds to the importance of this technology, that we develop this, because we can't let China to get this technology ahead of us. So I'm hoping all of our friends here online will join in that cause to make sure that the United States is the lead on this development.
Yeah, that's my hope too. Very funny. Another thing I like to share with you. I was kicked out from one WeChat group. The WeChat is like Facebook in America. Chinese community use that app. I was kicked out because there are patriots in the group. They feel like it's not convenient for them to speak their mind freely with me in it. So that's interesting. But
Well, you're American, right?
yeah, I'm American citizen. So anyway, they recognize that I'm helping them, and the official website, I built the website. I translate his book. I also help translate other people's paper to publish. Since they don't speak English, and also some of them don't have an academic background. Anyway.
But making it open source may be a good idea too. And if you make it open source, these ideas, maybe someone else, a genius somewhere in the world could come out with a solution which benefits the whole world. It's like, I'll give an example. In the UK, several years ago, they in Manchester, they discovered graphene material. Graphene was discovered here, and those ideas were spread all over the world, and several patents, were filed across the whole world. And now the whole world is researching, developing graphene with so many applications. So I suppose if some of this work is discussed across the world, and some clever minds there could make great contributions, rather than isolating yourself in China or somewhere else in the world.
We hope actually all those papers are available publicly. His theory is not hidden. It is public actually, although the book is not, but the content of the book has been published in those preprint.
One cannot
good.
deny
I
the
hope so.
advantages, though, politically, if a nation got a hold of this technology and protected it from others of getting it, if they had the ability to transfer armies by light speed from one continent to another, that could be very devastating and certainly controlling. So there's an absolute advantage if one country becomes the first at the top of the hill on this technology.
Yeah.
Terry, I noticed you post some comments. Can you speak up online? Terry wrote, the Zhang patent hypothesis that varying electromagnetic field can generate a gravity-like thrust. I don't believe it contains or reference any experimental tests of the hypothesis. And here he posts the abstract of Zhang's patent application.
Here, I just had trouble fumbling with the buttons to get the camera working on that. Yeah, I looked up the patent there and quoted the abstract out of it. I think it was a pretty good summary of the contents with that. By the way, I think someone asked earlier if that constant was a scalar or a vector. I believe it's a scalar as far as I can tell from looking at the paper, but I've given references for anybody who wants to look at the both Lynn Brand's paper. I don't know how to pronounce it right. Jiang, I'm sorry, Lynn, how do you pronounce his name?
Zhang Xiangqian is his name.
And Zhang would be the first, what we would consider the last name is first, right? So Zhang
is the last name.
Yeah, that always gets a little confusing as we switch back and forth between the orders there. So, but anyway, but I posted the information. I think the information is right that I posted. So that seems to be the correct patent. So.
So I'm looking through the patent as well, trying to read through that. What's lacking so far is more of a physics explanation of how this gravitation-like effect is actually. They explain how they would kind of experimentally or engineering generate it, but the theory behind it is not very clear where this transformation comes from. But it was accepted for a patent. That is very interesting. Very, very interesting.
Oddly enough, that is not the first time there have been patents that have been done on electromagnetic generation of field. The attempt of defining a gravitational force through electromagnetic, and actually it kind of goes back to Einstein, because he was very interested in, literally until the day he died, in trying to find a unified field theory of gravity and electromagnetics. So if you look through the patent records, you can find, I know I've seen some, but I can't think of a specific example that I could reference immediately. But of other, if you look up some of the
Terry, going back about 35 years, I was involved with some research which was not conversion of electromagnetism to gravitation or anything like that, but was actually generation of a gravitational effect through time varying gravitomagnetism.
That might be the same. That might be the same work I'm thinking of, because this was, that may be a little far. I think I've seen some stuff more recently also on NASA has had space propulsion units where they've speculated.
Yes, that's it. Yes, that was what that NASA had its own independent group. I was part of another group. But yes, that was what that was related to. Do you ever hear of a name, Ning Lee?
I'm getting too old when I think of things like that as being more recently, and it actually probably was back. Yes, back a ways.
Yeah, well, I'm probably about as old as you are, so yeah, I can assure you it was back a whiles back.
Okay. I think it has. I'm pretty sure it has been has come up again, shall we say? So because I remember, in terms of the first time I remember seeing work like that, that sounds about right. But I know I've seen some things more recently, even at work, because we've had cases where our group would be assessing technologies and looking at different concepts, and I think it popped up at some point. But
that I've not heard of. That would be interesting.
Yeah, I'd have to look that up. But that part of it, I'm quite sure is much more recent, but I just don't remember the full context of it. And I do believe NASA was involved. NASA has a history of actually looking kind of off and on at looking at different technologies. The idea being that it's very high risk, but of course, as you noted, if you can get something like that to work, then you would be a very high payoff, sort of the venture capital model. It's high risk, but if you get a hit, it has an enormous impact on what's going on.
I think I had heard that Skunkworks was looking at something involving this kind of physics, but it was kind of a vague reference.
Yeah, most of the recent ones I think were literally called warp drive. If you looked up warp drive in NASA, I think you would probably find some of the ones I was thinking of. And I believe they involved electromagnetics, but I could be wrong in that. It could have been that's my best recollection. Was that also
this was not warp drive, but although theoretically, I suppose it could. I don't think it could lead to even that, but it was exotic enough.
Yeah, this and that may be where I'm cross-linking because I know they use the term warp drive, and I say look up warp drive, NASA probably get hit on those. Those within the last 10 years or so.
There is a great deal of work on warp drive, a great deal of theoretical work on warp drive, trying to find out if there's a way to actually generate that without using physically impossible or for all practical purposes, impossible metamaterials to actually generate that with negative energy, for example.
It always
so there is a great deal of theoretical work on that. The famous Alcubierre method of generating a potential warp drive has kind of been modified and generalized by a lot of people. But the people at Applied Physics, I think it's called, that company or that conglomerate of theoretical and experimental physicists, I think have done a good deal of recent work on that.
Yeah, the one that they always pop up, you mentioned materials, the metamaterials. The theories work fine if you can find a magical substance called negative mass material of some sort. So wormholes, same thing with wormholes. Actually,
correct.
I think for the same reason.
There is a paper or some research work by someone called Alcubierre, Miguel Alcubierre.
That's what I just said. Yeah, that's what I was referring to.
He developed a kind of theory for
Yes.
for a ship working those principles.
Yeah, but it's gone beyond. He originated it, but in the last 25 years or so, it's gone well beyond that. And a lot of people have jumped into that to try to actually develop that. When the effort is basically to try to get those metamaterials that are necessary to do this to back down to some kind of conceivably not normative, but at least within the technological grasp of humanity at some point. Right, because originally, but at his back in the original paper, Alcubierre and related papers back then, it was simply inconceivable that could ever be a practical material. And so there has been some success in that. Most recently, I think, by the physicists at applied physics. That's still wildly exotic, but it's much more normative than the original concepts around the time of Alcubierre.
Yeah, what's interesting about that whole area is if you give the assumption that you can have these exotic materials, then the mathematical exploration uses a lot of fairly standard relativistic physics, and you get a number of really interesting results. Of course, but then it always goes back to that, just as you were saying, that then they have to say, yeah, but can that really exotic substance actually exist or not? And so you get different variations where they try to do it. I don't know if there's, Lynn, I don't know if there's an electromagnetic interpretation of that. I don't think there is. I think that's more, I could be wrong. I don't know much. I'm not well versed in Einstein's unified field theory attempts. I know he tried to do something like that. But yeah, so, and like you say, it's been a surprising amount of work. But again, you got that critical assumption that there's an easily accessible form of negative, I believe it was negative mass energy. Does that sound right?
Not from
anti-gravity.
Yeah, it's well, and it makes sense. If you have negative, what happens if you have negative mass, you can start doing all sorts of things with spacetime because you have negative curvature on spacetime. So it's not a coincidence that the concept that it gets invoked in both wormholes. In wormholes, I think it's used as a bracing material where you have to kind of keep the wormhole from collapsing. So it gets into some pretty interesting turf.
Adding some dots to these ideas, if that's possible to generate gravity or anti-gravity using electromagnetic fields, then if you combine with fusion, nuclear fusion, if you combine with nuclear fusion to generate electricity, and that nuclear fusion, electricity, magnetism to anti-gravity, that is going to be incredible.
I have an adorable granddaughter coming into my office here. We're babysitting our granddaughters today. So where was I?
Are you training her to be a quantum physicist or a gravitation theorist?
My granddaughter is one of the smartest people I know, and I'm not kidding. That she'll sit there. A lot of kids, you say something to them, and they get quiet. And you think, oh, they forgot what I'm talking about. And she'll come back, a few seconds later, and she's analyzed it, and she's going in and thinking about it. So little girl you just saw, she is a deep thinker, and she's a deeper thinker when she was 3 than some people I've met than when they were 60. So such is the variety of how we all have our approach, and she definitely likes to look at things. One of the ironies, I'll mention this, I'm reluctant to mention it because I think it's a tangent, but on the version of the standard particle model that I use, which is in some of the presentations I've given, and I think I've mentioned this, but I do a very unusual thing, which is that the non-weak force particles, the non-weak aware, the weak blind particles, I call them. Every particle you think like an electron, a quark, take your choice. It's actually 2 particles. And one of them has one chirality, one mirror image, the other one has the opposite mirror image, but they're not identical. They behave very differently in one point. Some of them can see what's called the weak force, and the other ones cannot see what's called the weak force. And when you put those two together, we get the particles that we think of. And it is my own hypothesis, which I've not a trivial one, that we're missing something in plain sight, which is that the weak blind particles are negative energy, that they actually have no mass. And the reason that our universe has mass is we have an excess of the positive mass helices, which then create pairs of the other ones. So the superb irony is there that even though I'm not trying to bring it in this context, is I'm saying that half of the periodic table is negative energy matter. We just don't know it, which I don't know. I just find that hilarious, the idea that we might be overlooking something that incredibly important right there in the standard model, fully documented, mathematically precise. It's just a slightly different interpretation. So the Higgs boson reaction becomes part of how time unfolds, because it's an interplay between these two different types of a slight excess of positive mass and a slight excess of this negative mass. So you can't get much of this stuff because it always annihilates in our universe. It's going the wrong direction in time, but it's there, and it actually is part of how time was created. So how's that for an exotic theorist? Sorry, didn't mean to get into it. It's irrelevant in this. And again, that's a Terry hypothesis. That's not from the textbook, but I stand by it and I say, yeah, half of what we already know about is negative mass. We just don't know it yet. We'll get around. Well, that would open up some interesting possibilities, wouldn't it? What if you get an excess of the wrong helicity, of wrong chirality of these particles? You would have something that might make all sorts of things interesting. Lynn, can you still hear us?
Yes, I can.
Oh, okay. There were some comments about breaking up.
It's fine to me.
I'm going to be quiet here. I'm talking too much. Yeah.
Any other questions for me?
Can you come back again for another presentation and describing this patent, if it's possible?
You want me to present the patent?
Or the experiment in more detail?
Okay. If yeah, yes, I can do that.
That would be great. Yeah, thanks.
Yeah, that Helen.
Yeah, sure. We're pretty much open in March.
Okay, then yeah, we'll schedule for March then.
Sure.
I'd like to hear you say a little bit more on that helical effect, the spiral emergence.
When I hear the concept of space having density, it makes me think of some of the early work in physics where it was assumed there was this thing called the ether. How does this new concept differ from that, or is it something similar?
And I don't know about ether, but the density is I don't think it is mysterious. Ether, I don't know what it is, but it seems to be very mysterious something. And the density, if we treat space as medium, the medium requires speed and density. So the density is just intrinsic property. It's not mysterious, not at all.
Well, purportedly, the Michelson-Morley experiment back in the late 19th, early 20th century ruled out the presence of an ether, which is one of the revolutions that ultimately led to quantum mechanics and also relativity. So I think that's what the other gentleman was referring to. There was this idea that space had a substance was the assumption in 19th century classical physics.
But
then it was seemingly ruled out experimentally.
Right, but the missing part, they didn't know where this density comes from. if you don't have this axiom to say that space is moving at light speed, and then you don't have the origin of the density itself. The quantum physics has existed for so long. They has detected the motion of space actually, but they just because of they do not acknowledge it is a medium. It just never complete. It's still mysterious, the quantum world. But the John's theory says it's not mysterious. It is a very explainable. It's a geometry. Yeah, geometry. Just we just have not acknowledged it. Space is a medium. We use it. We define the speed for it. We observe it. Everything. I mean, quantum is trivial, as I presented in the paper. It already says that space is medium. We just have not explicitly explained it. That's why we have not assigned it the density property.
We got a request from Maya. She asked, Lynn, please continue to share and translate all the research you can. This work is very interesting.
Yeah, I'm glad to. I mean, I'm glad to. I'm grateful to have this opportunity to advocate for this theory. I believe this theory is true. So someday, maybe you see me to get some Nobel Prize.
But can you use ChatGPT to translate from Chinese to English, and then you can verify the content?
ChatGPT definitely could translate. However, if somebody doesn't speak English at all, they cannot know if it is correct, right? Yeah. I use ChatGPT a lot for translation, especially now that 5.2 has come up. It's almost I don't need do much edit. But last year when I translated the book, it was different story. At that time, ChatGPT couldn't translate accurately. And also at that time, since the theory is so new, ChatGPT didn't really understand it either. So it was not easy last year when I translated the book, but now it's a different story. Now when I get a paper from those Chinese independent research, I plug in and I translate and read almost, it's almost already done. Yeah.
So Paul is wondering where are our books available? Website?
Oh yeah, that Hope Grace Publishing. Yeah, I have a website, hopegracepublishing.com. It has all the John's book, and I write my own other book too. So.
And Terry comment much of modern physics have drifted back to what amounts to an ether theory, quantum field theory being the main example. A space filled with resonators is unavoidably a lot like an ether.
Say again, what's that?
Terry, can you unmute? And
it's even though technically everybody respects the results of special relativity, and they're extremely well proven experimentally by gamma ray experiments and Hawsey experiments in 2020. Any frame, doesn't matter how fast they are, they see the same physics. That's just the way it is. So that's just a given by the experiment. Nonetheless, the theories which attempt to explain that are actually basically ether theories. And I've heard Roger Penrose in his own voice and on a chat session with Astrophysica a few years ago, we expressed surprise that he found that relativity doesn't break, because basically he thought, as many physicists do, but they won't say it out loud, that it is really an atomic ether. So it's remarkable how much physics has drifted back into an ether theory, even though they claim, especially publicly, that they haven't. But when you push on it, you find out they kind of have. And the reason is quantum field theory, because quantum theory is a bunch of little vibrators. They just one of them goes this way and it knocks the other one that way, and off they go. And that's the basis of modern physics.
Yeah, actually,
It's extremely well proven theory for local small effects. It blows up completely for galactic scales, but it works great for small scales. So we have some interesting paradoxes in how we do this. You were saying, Lynn?
Yeah, you remind me of a recent paper I saw, an experiment. They also transferred, induced gravitational field from magnetic, electromagnetic field energy, but they couldn't explain something in their experiment. I don't remember the details, but John read that paper. It was translated to Chinese. He read that paper. He contacted that author of that paper, saying that the part you think unexplainable, I can explain with my theory. But that author didn't respond. So yeah, as you said, there are many experiments now. They all observe same thing, but no existing theory can explain it as clearly and logically as John's theory. Yeah.
Can I ask another question there?
You have to remember the name of that. Oh, sorry.
Yeah, Karen, Terry, sorry.
No, I just wonder if you remember the name of that paper that Chang looked at. Do you remember what the name of the paper was?
I could find out, because that among the John's fan base, that paper was discussed quite a while. Yeah, I could find out, and I gave to Helen. They can pass along.
Okay. Yeah, because the paper on gravity effects of electromagnetics, I gather that's what it was
Something
about.
like that, I think. Yeah. So yeah, that paper was published. It was a big news. That's why John was able to read it, and it was also translated into Chinese. And then he tried to contact the author. Told them in their paper, they said there's some unexplainable observation. That's why John contacted them, saying I could explain. Yeah. So anyway, I can definitely find that paper, because it was discussed for a while among John's fan base. Yeah. I probably could include that in the slides, since I will give it to Helen for her to send out. Yeah, I could.
Oh yeah, if you would, that would be nice.
I could add that on the last slide.
Lynn, can I query? I had another question. Earlier on, you mentioned a few occasions that the density of space it varies. It's constant, but it varies. I wonder, how does it vary with the universal expansion? And since the Big Bang, the universe has been expanding. So is there any correlation between the variation of this constant density with the universal expansion?
No, this is actually John's theory explained the universal expansion. Okay, he repeatedly say the motion is cylindrical spiral. So how could the spiral and the cylindrical? The cylindrical is the basic unit shape that is a cylindrical shape. However, when you stack one cylindrical on top of another, the further away the cylindrical's perimeter is longer. So if you look at the big picture, that is a fan. It looks like a fan. It's not a cylindrical. Cylindrical is only at the unit, the base unit scale. But when you look at the big picture, it is a stacks of cylindrical, and each cylinder on top of it would have the surface is pi r square. So when you increase r by 1 at base, and then the second r became 2. 2 square is 4. So the fan shape actually expand very fast. It is not 2 times. It is a square, r square. That's why the universe, we think it is expanding. It is just a natural thing, since when the r becomes larger and larger, it is the surface become pi r square. So of course, the further away the edge, there's no edge probably, but the further away it is wider and wider. So that is why it is appear to be expanding.
Lynn, I may be going off on a tangent inadvertently, but the first thing that came to mind when you were talking about the spirals was protons. And the reason is this: the quarks go in 3-dimensional space and they circle around and they're bound to each other. They can't escape. So they're always spiraling around each other. But if you put that in time, you get the 4-dimensional equivalent of what we would think of as a cylinder. They carve out a shape that's a 3-dimensional ball, but in 4-dimensional space, that's the surface that you create a 4-dimensional cylinder. So there's a geometry there that just an ordinary protons that is a 4-dimensional cylinder, and it has a time component to it because those quarks going around, that's the oscillation that measures out time in a proton. So every proton has a clock, every particle has a clock. They all have a clock. They all spiral in some fashion that we don't quite understand. But in the case of the proton, it's especially vivid because they form the geometrical equivalent of a 4-dimensional cylinder. Every proton does that. Now, I think you were talking more about some global scale, but just to give an example of that kind of geometry, what the shapes we see in 3-dimensional space have their equivalents in the higher dimensional space, and cylinders are an example of that. So you have the 4 dimensions turn into something. We could see it in certain views as a cylinder, but of course we can't see it completely because we're 3-dimensional. So we have limits on what we can visualize.
Yeah.
And again, that may be a bit of a tangent, I'm not sure, but it certainly struck me when you're talking about the spirals going through time. That is a component of physics regardless, because every particle that goes through time has a frequency, and that frequency is the ultimate determiner of time. Without that frequency, you don't get the idea of a time flow from the particle.
Yeah. So anyway, since I feel so safe with you audience here, I'd like to tell you the story of John, how he got this theory. Yeah, the background story. He is actually a farmer. his only junior high school formal education. He claimed he was adopted by aliens in 1985, summer 1985, when he was 18. And then he lived in their planet for a month, but only one night on Earth. When he came back, he said they imprint this theory in his brain. That's why he got this. And of course, he couldn't understand, but he remembered. So he wrote it down. And well, he wrote it down. He still didn't understand. He started to study it on his own. But as a junior high school education, he couldn't really understand it fully. But enough for him to tell the story and wrote the book. Yeah, that's and when I heard that story, somehow I believe it was true. And when I translated his book, it makes so much sense to me. So that's why I believe it is a real theory, regardless his origin. I know this when I told people about this story, they just dismissed this theory immediately. Normally, they even probably think I'm crazy. But on the contrary, because of the origin of the story, I believe it is real. Yeah.
Jack Sarfati told the story that he was contacted by an alien by telephone when he was about 13 years old, back in the early 1950s, and didn't hurt him. Basically, turned into a semi-genius apparently. But that is an interesting way to come about a theory, to be abducted by aliens. That's
Yeah.
That's doing it the hard way.
And yeah, but since I heard his story, I just if it didn't happen that way, there's no way he could write this theory. That's the reason. And also he devoted his lifetime on it. If he was lying, why would he do that? He was actually persecuted by Chinese government. They came to threaten him not to spread lies. If he has to tell, he can. He was allowed to talk about his experience as a fairy tale. Yeah, and the Chinese government also confiscated his manuscripts, but he kept on telling. Yeah. Yeah, there are people like myself who believe his theory. There are also many people hate him. Yeah, they threaten him.
Well, physical threats or such suppression is extremely unfortunate under any circumstances, and that is very unfortunate. Whatever the validity or invalidity of his theory is.
Yeah. Anyway, when I translated his book, it makes so much sense to me. That's the real reason I was convinced this theory makes so much sense to explain all the physics every day, the real world. I mean, it's certainly better than string theory.
Did he develop other theories or just only this theory? Has he developed other theories in science or engineering, or is just only this particular subject?
only this one. Yeah.
Okay, that's very unique. You know, I'm a bit skeptical about aliens, but I cannot prove right or prove wrong. You know, but that's the reason I was asking about if he has developed other theories and so on. Yeah, it's okay. Yeah, thank you.
Yeah, no, his formal education is just a junior high school, so he doesn't really have any scientific training. He just taught himself to understand his own manuscripts. Yeah. Over so many decades, probably some of them he doesn't remember clearly.
And Paul asked, how did you meet Zhang?
Oh, how did I meet him? Last year, his story became so popular in Chinese community. There are two largest YouTubers. One has 6 million subscribers. Made a video of his story. I happened to watch it, and then during the video, the host saying, if you are interested, you could contact him through Bilibili account. And then I didn't have Bilibili account. Bilibili is like an American YouTube platform. But without account, a user is allowed to send one free message. So I sent that message to him. Fortunately, he responded. So we got connected. We talked over WeChat, and I said, I want to help you. I believe your story is real. And so the first thing I can see is to translate your manuscript into English. Otherwise, your theory will never have chance to be recognized, since nobody would read it if it's only in Chinese. So he gave me his transcript. I translated that. That's how I got to know him.
Yeah, thank you very much for this presentation. It's been nearly 2 hours, more than 2 hours, and we're still debating. That shows that the topic is quite interesting. And your presentation very good too.
Thank you very much.
And Paul has another question. What is the next step?
I could give another talk. Yeah. I appreciate the kindness of this audience.
And Terry just says superstring theory is indeed a good example of an idea that was good for about 5 papers, but then took on a life of its own, almost totally disconnected from experimentation.
Yeah, I mean, it is. I just feel so unfair because of the creator of that theory is famous, and then so many decades of effort put into it. Wasted basically. But with this John's theory, it's so direct. You can just disprove it so quickly. Nobody would even give a chance. So. Okay. Thank you very much. I really appreciate this opportunity and your kindness. Yeah.
Yeah, we're looking forward for your next talk, maybe in March, maybe.
Okay.
If possible.
Mm-hmm.
Yeah, and Terry will be our next one in January, and on January 17th, Terry Bollinger.
Okay.
So do anyone have more questions?
Just saying good Christmas to everybody, and Happy New Year.
Yeah.
Thank you.
Thank you.